For this objective, we're going to be talking about graphing systems of equations. And the essential question that we're going to be talking about is, how can I solve a system by graphing it? All right, so that's our essential question. If you need to pause for a moment, go ahead and do that to catch up with me. We're going to run through some notes, and then I'll do a couple of examples for you. But as we proceed through this, please try to follow along and pause anytime you need to. I also apologize for the echo if there is one on the video. All right, so the first big question that we're going to ask is, what is a system? And so I'm going to start with an example. An example of a system is something like 4x plus 2y equals 3 and y equals 2x minus 4. That is a system for two reasons. One, a system usually, I'll do better than usually, I can say always, has more than one equation. A system usually has more than one variable. And so a system is basically, when you get down to it, and this is maybe the starred definition, a system is a pair or more of relationships that work together. And so, I'm going to put so, a solution to a system. A solution to a system makes all the relationships in the system true. Okay, so when you think about this system up here, it's got two equations, 1, 2, and it's got two variables, x and y. And so a solution will have x equals and y equals for both equations. And I think to understand that, it's best to look at an example. And so I'm going to write the next big question, which is, what does the graph of a system of, I'm going to put in parentheses, linear equations look like? I'll kind of put this bar here so it's easier not to confuse. I'll change colors. What does the graph of a system of linear equations look like? So for the system y equals 2x plus 3 and y equals negative x plus 5, it's going to look like this. I'm going to have a coordinate plane. And on that coordinate plane, I'm going to graph both things. This one starts at 3, so maybe around there. And it says it goes up 2 over 1. So it's going to have a slope that kind of looks like that. The second equation here starts at 5, so maybe up here. And it's going to go down 1 over 1. And so it would go down like so. And so then the spot, maybe the most important point that you can notice, is the intersection of the lines is the solution. And if you think about this thing that we wrote up here, which is that a solution to a system makes all the relationships in the system true, I've got two relationships. I've got two graphs that are shown. I've got this first graph and this second graph, and the only place where they're both true, where they both exist at the exact same moment on the coordinate grid, is that spot where they intersect. And so the fact that they're both there at this spot at the same time means that that's the solution, because both things are true right at that spot. And so at this point, what I'm going to do is give you a little description here. A system looks like two lines graphed. Their intersection is the solution. That's going to be fairly well it for notes. So I'll have you guys do the summary here, but I will work through a couple of examples. So let's go ahead and do that. I've got this example on the board here. And so I need to be able to graph these two things. And when you're looking at these exercises, the blue corresponds to the blue line, and the green corresponds to the green line there. And so in order to graph the blue line, I'm going to do a little bit of work. I have 3x minus 4y equals 20. Right now, I'm not actually sure how to graph it. If it were in y equals form, I would totally know what to do to graph it. And so I'm going to take a moment, and I'm going to put that in y equals form. And so the first step I'm going to take is I'm going to take away 3x, because I'm solving for y here. So everything else has to leave. We did this a lot last semester, so this should be kind of a review. So then I'll end up with negative 4y equals, these 20 and negative 3x are not like terms, so they stay separate. So I have negative 4y equals 20 minus 3x. And then I'm going to take one more step here, because again, I'm still solving for y, which means I need to get rid of the negative 4. It's multiplied by y, so I'm going to divide by it. And so I'll divide everything on the other side by negative 4 as well. And so I get y is equal to 20 divided by negative 4 is negative 5. Negative divided by a negative is going to make the next thing a positive. And I'm just going to write the fraction 3/4. Sometimes you have to reduce that fraction, but it's helpful to have a fraction when you graph for the following reason. So now, all right, and so I've solved and gotten y equals negative 5 plus 3/4 x. And now I can do a little bit of reading there to try to figure out what that means in order to graph it. And so this negative 5 here means it's going to start at 0, negative 5, because it does not have the x by it, it's the y-intercept. And then this means that it's going to go up 3, right 4, because it's rise over run. And that's equal to 3/4 in this case. And so I'm going to start my line down here at negative 5. There it is. And I'm going to go up 1, 2, 3, over 1, 2, 3, 4. So I've got my blue line graphed at this point. All right, so let's solve the green equation for y now. So I have negative 6x minus 4y equals negative 16. I'll start by getting rid of the x term. So I'm going to add 6x to both sides. And so I get negative 4y is equal to negative 16 plus 6x. Now I need to get rid of the coefficient for y, so I'll divide by negative 4. And so you get y is equal to negative 16 divided by negative 4 is positive 4. A positive divided by a negative is going to be a negative, and then 6 over 4 reduces to 3/2 x. And so I can go ahead and graph that. It's going to start at 4. Because the number here is 4, so it tells me 0, 4 is the starting point. And then minus 3/2 tells me I go down 3, right 2. Because you always move to the right, the negative just applies to whether or not you go up or down. So I'm going to, on this line, I'll go down 1, 2, 3, and then right 2, and then I end up with this spot on my graph. And that spot is the solution. And so I have to find its coordinates. If I look up at the x-axis, it tells me x is equal to 4. If I look over at the y-axis from that point, it tells me that y is equal to -2. And so when I type in my solution here, I should put in x equals 4 and y equals -2. And it plays a little chime for you now. So if you need any more help with it, please make sure you show me the notes. Don't forget, please, that when you are done watching this video, you should go back and write your summary. In order to write the summary, you want to think about some of the most important things that we talked about, and then whatever's going to help you remember this in the long run. So if you need any help thinking about how to write that summary, make sure you do so before you go on to practice. Thanks.